Okay, this is the M1 paper from October 2020. This is question number 6, which if you look at it, you can see this is quite tough, connected particles, and it's on an inclined plane, and we've got a thrust going on in this question. It's going to be all about drawing the diagram, the force diagram out accurately. We've got resistances, we've got lots of various bits of detail to look at. So have a quick read of the question and then we'll get started with it. So we've got an engine and a truck. The engine's 1,500 kilograms, the truck is 500. Connected by a coupling, so that's going to make a difference to which way the forces go compared to tension in a string. It tells me that angle alpha, where sine alpha equals 7/25. That's quite useful. Sometimes they give us tan alpha, and then I need to work out sine and cos, but they've given me sine alpha because sine alpha is the one that I'm going to be interested in doing. Engine produces a driving force of magnitude d newtons, so we've got this driving force acting up there. We've got a resistance of this one and a resistance of this one, and we're not using F equals mu r here. They're telling me what the resistances are, and it just says with the coupling being modelled as a light rod, can we find the acceleration of the engine and the truck, and then can we find the value of d? So yeah, we can. We're just going to need to draw a really good diagram out in the first instance. So let's make a start with that then. So I'm going to make it nice and big. Lots of detail going to be going on this. So I always encourage my students, don't skimp with your diagram. Make it big enough so you can fit everything on here. So I'm going to draw my first one just as a particle here. This has a mass of 1,500 g. Obviously, because it's on a plane, we're going to have a reaction force there. This is the engine, so I'm going to call this RE. Even if I don't need these forces, I'm going to put them on, and then I'll worry about what I do need and what I don't need later on. We know there's a driving force here. I'm certainly going to be using that one. And then what we've got is the truck there. Well, straight away, let's talk about this coupling. The coupling is, what does it tell me? It tells me the coupling is 2,000, and that's going to go in the opposite direction to where we would think that tension, if it was tension in a string, is. Okay, we'll have another reaction force coming out here. This is the reaction force of the truck, and we've got the weight of the truck going down there, and that's going to be a weight of 500 g. And then if I was to resolve these two forces, which I'm going to do straight away here, I'm going to have that this one, if I was resolving this, that's alpha in there. This is going to be 1,500 g cos alpha, and more importantly, this one's going to be 1,500 g sine alpha. And then if I do the same thing over here for the truck, that's going to be, again, that angle there is going to be alpha. You can look at other videos of mine to see where that comes from. I haven't got time with this one here where we're going through doing the diagram in such detail. This would be 500 g cos, and this would be 500 g sine alpha. Now, we're not actually going to be using any of these parts simply because they've told me what the frictions are. I don't need to do F equals mu r. They're actually telling me that the friction, the resistance forces on that one is 500 newtons, and the resistance on that one is 1,200 newtons. So that takes out any business about F equals mu r and having to resolve parallel and perpendicular to the plane. Still put them all on. Remind ourselves that sine alpha was being given as 7/25 from the question, and that this whole thing is accelerating up the plane there. Now, because I've got all my forces on there, I can now just imagine that in this direction here, I've got F equals ma. But look at all these forces that I've got going on in that direction. So what I need to do is to try and identify, am I going to do the whole system? Am I just going to do the truck? Or am I just going to do the engine? Well, I'm looking at it, and D there means that I can't really use this system, and I can't really use, I can't really use just the engine, and I can't really use the whole system. So actually looking at the truck, I've got that force, I've got that force, and I've got that force, and I know all of those. So that means that I should be able to work out the acceleration using that one there, because it'll be the only thing that's unknown. Right, that's explained it to you. Now I need to explain it to the examiner. So I'm going to say, consider the truck. So let's make it clear to the examiner which part of the diagram I'm looking at. F equals ma, which is going to give me, now as we say, because I know it's accelerating in that direction, then that force, the 2000, supersedes the 500 and the 500g sine. So when I'm doing it, 2000 minus the 500 minus the 500g sine alpha, all of that is going to be equal to mass times acceleration, which obviously is 500 times acceleration. So the only thing we don't know there now is acceleration, because we've got 2000 minus 500 is 1500 minus 500g. Sine alpha was 7 over 20, 7 over 24, 7 over 25, sorry, 7 over 25, apologies. 7 over 25 is equal to 500A. So work that out, divide it all out. A works out to be equal to 0.256, but we've got G involved, so let's call it 0.26 meters per second squared. Fantastic, right, that's acceleration worked out. Now I'm trying to work out what D is, and if I'm trying to work out what D is, get rid of these highlights in my diagram, I can now consider just the engine, and I've got D, 1200, 2000 and 1500 G sine. All those forces are going to be acting. So let's talk about those. Consider the engine. And I'll tell you what I didn't put in here, which I should have done. I should have said resolve parallel to the plane. You'll see that on all my other videos. I'll do it here. Consider the engine, resolve parallel to the plane. F equals ma. So yeah, we've just got those forces. So we know it's accelerating up the plane. So D is going to be bigger than the 2000, the 1200 and the 1500 G sine alpha. So when I'm doing that, it's going to be D minus 2000 minus 1200, that's the thrust and the resistance forces, minus the 1500 G sine alpha. All of that is going to be equal to mass times acceleration, and this time, because we're considering the engine, is equal to that. But we know what acceleration is now. So this is D minus, well, that's 3200. That's 1500 G, 7 over 25 again. And that's equal to 1500 times the 0.26 that we had. I'll use the whole number, but I'll put 0.26 there. And we're done. Just rearrange all that. Just take those ones over to the other side, add them all on. And D works out to be equal to, well, I'm going to do it straight away, to the correct number of significant figures as well. If we do it and we tidy it up, D works out to be equal to 7,700 newtons. So yeah, people don't like these questions where we've got connected particles going on an inclined plane, but hopefully that one makes sense to you.